Okay, here's another equation, literal equation, and is it a doozy? It's from statistics, and it's a little advanced for this section of the book because we haven't discussed squaring terms or taking square roots in an equation. But I thought I would just work this through from start to finish. Try to follow me as best you can. And the thing is to listen for the logic that I'm using in solving this problem. Alright, so here it is. Solve for letter R. T equals to R divided by the square root of 1 minus R squared over n minus 2. Alright, so we have to solve for R. And it looks a little kind of a bad equation, but it's not as bad, quite as bad as it looks. Alright, now this comes from statistics also, and it's related to fitting lines to scatter plots of points. It's called a regression line. And this is related to testing whether a line has a positive slope versus a zero slope, or testing it for having a negative slope versus a zero slope. Alright, so that would make a lot of sense if you study statistics. Alright, so first thing I'm going to do is get rid of this big denominator. So I'm going to multiply both sides by the square root of 1 minus R squared over n minus 2. And that's going to clear it on the right side, but it'll reintroduce it over here. So I have T times square root 1 minus R squared over n minus 2 equals to R. Because again, on the right side, we canceled the fraction. Alright, now I realize I still have a fraction here, but it's not as bad as it was. Now, that square root, not much I can do with it, except get rid of it. And the only way to get rid of it is to square it. So I'm going to square both sides of the equation. Alright, so that's something you would do in the next chapter, but I thought I would go ahead and introduce it to you here. When I square t, I get t squared. And when I square the square root disappears. So that gives me 1 minus r squared over n minus 2 equals to r squared. Alright, so I hope you're doing well so far. Again, try to follow each step and the logic in working this out, which I think is valuable to this problem. Alright, now I'm going to get rid of this fraction, or this denominator, by multiplying everything by n minus 2. So, multiply by n minus 2. Now on the left side, the n minus 2's cancel, so that gives me t squared, parentheses, 1 minus r squared, equals to r squared times, parentheses, n minus 2. So that canceled that denominator. It sort of transferred the n minus 2 to the right side. And now it doesn't look so bad to me because we got rid of the square roots, we got rid of the fractions. And I need to make room on my board. So let me do some erasing. Okay, I've transferred the last line I had up to the top of the board. And our goal here is to figure out how do we isolate the r's, the r, or r squared. And since I have just r squared right now, I'm just going to concentrate on getting r squared by itself, and then we'll deal with getting r. Alright, so let's see. I need to get this out of the parentheses in order to move it over to the other side. So I'm just going to multiply r squared through both parentheses here, and by distribution. So this gives us t squared minus t squared r squared equals, and here I've got n times r squared minus 2r squared. Alright, now I have a term over here with r squared in it, so I'm going to add this to both sides. And when I add it to the left side, it cancels. So in a sense, we're sort of transferring it from one side to the other. I have t squared equals to n r squared minus 2r squared plus t squared r squared. All right, now what do we do? Well, now we've come to a punchline, which I like about this problem, and which I wanted to show you. And you'll run into this sort of situation in a few problems in your book, where you end up with the letter you're trying to solve for appears in several different terms. I have r squared, r squared, r squared in each of these terms. How do we isolate r squared? Well, we can factor it out. When we factor out r squared, then we have a single r squared multiplying other stuff. So let's see what that looks like. I got t squared equals to, factor out r squared, is my common factor, n minus 2 plus t squared. So I have r squared times this number equals to t squared. If I divide both sides by this number, in parentheses, the n minus 2 plus t squared, n minus 2 plus t squared on the left side as well, then everything goes here, leaving r squared equals to this mess. So let me write that mess down. R squared is equal to t squared divided by n minus 2 plus t squared. Alright, so almost done. And we need one other step that hasn't been introduced yet in the book thus far. And we'll get to this in the next chapter. But when you solve by taking the square root of both sides of an equation, you introduce two answers, a positive and a negative. Alright, the neat thing about this statistics problem is that it literally does not matter if you got positive or negative. So I'm not going to worry about that issue on this problem. When I take the square root, I'm just going to write square root. Alright, if you didn't quite follow all that, it'll make more sense when we do the next chapter. So to solve for r, I'm going to take the square root of everything, both sides. So that will allow us to write the answer. And this answer can be checked in the original problem. It would be quite a mess to do so, but it can be done. So r is equal to, and look here, when I take the square root of t squared, I get t. So I get t divided by the square root of n minus 2 plus t squared. So there we go. Now I actually use this sometimes in statistics. Our Math 160 textbook gives us the original problem I put up there, does not give us this form. And so occasionally when I'm teaching that class, one or two occasions I like to use this form. So I had to solve that equation for r myself. And there it is.